think I'll go out at this high point. How many people here actually work in healthcare? Okay, excellent. How many people are familiar with NLP and deep learning in NLP? Oh, excellent. Okay. So we're going to do a really brief introduction on really where NLP is today and what's happening in the healthcare space, because we are really in amazingly exciting times in 2019 especially, but this all last few years in terms of what's become possible. And then we're going to talk about really three things I've learned. I'll tell you my background. I mean, I finished my PhD in 2006, chose industry, and by blind luck, got involved with some of the early projects that actually implemented those technologies. So I have the benefit of having made quite a few mistakes and learned from them. So the goal is to show some of the basically principles or things I've learned from implementing those systems kind of in real use cases. So that's the goal. We'll have questions at the end, but please ask as we go. So, anyone familiar with this graphic? In 2017, IEEE Spectrum started keeping score of AI versus doctors and started tracking the papers that actually compared them in kind of what they considered fair comparison statistically, and showed where the humans are still beating, where is it a time where AI wins. And of course, the main thing is basically it's only going that way. Every year there's more and more that goes that way. The problem with humans is that they don't really improve much, right? Especially, really, it takes like 20 years to train an expert, and that's like the really good people, right, to stick with it. But that's it, right? So if you want to know, error rate in understanding, really diagnosing, oncology, diagnosing cardiology, right? We have a handful of really good people, right? They're in Israel, right? There are probably 100 people who can do this really well. Right? That means, sometimes there's a 70% accuracy, sometimes there's 80% accuracy, and that's it. Okay, so first of all, most of us, when we get sick, will not get to meet those people. Okay, and the other thing, the real problem is that 80% curve, mostly in many cases, has not changed since the 70s or 80s. Right? So when we have a new technology like MRI, we improve. But those, those are the cycles. And now we have an opportunity to do better. So in 2017, the main choice was, yes, you can do specific things. But can you understand really the human emotion and nuances? And 2017 was the year where there were like 4 major studies that show what we all intuitively know, that humans are actually horrible at understanding other humans and what's going on with them. And especially in the area of mental health, we really need to listen to people, right? And try to see, are they really suicidal? Are they really going through a psychosis? Actually, it's easier for machines to do it because they actually don't stop listening. They don't get bored. They're not prejudiced because people look a certain way. Okay, so that was 2017. 2018, the next big question was, okay, so you can do these really, really specific things. You have one diagnosis and you can do it well. But you can't just, look at a patient and tell him what's wrong with him. In 2018, there were 2 very famous research papers, both from China. They took on the general case. So one thing that happened was passing the Chinese medical licensing exam, where more than half of the questions are case study questions, right? So it's these 2 paragraphs. Patient presents with ta-ta-ta-ta, they claim that ta-ta-ta, the mother says ta, and they're on this medication, what would you do next? Okay, so this is not, here's a nice x-ray that you're this straight, and what do you do with it, right? It can be anything. And the other thing was, in China, they have the same problem that there's everywhere. Not enough doctors for the population. Okay, just this is population growth. This is how many people we can educate. Right, it just gets worse and worse. And they actually looked at 600,000 kids. And this is like ER. Okay, you come with your kid to the ER. And you tell them, well, here's why I'm here. Okay, because they've been coughing too hard for 2 days, and I saw blood here and whatever. And so they actually outperformed the doctors in diagnosis. Okay, so we're beginning together. 2019 was a really exciting year for NLP, because it's the first year actually in March. Here's what happened. We had an algorithm that actually beat humans in general question answering from Wikipedia. That was the Squad 2 dataset. And in the same month, really, there was first time also an algorithm beat the human baseline in ProQA, so conversational Q&A. Okay, so when there's a conversation, you actually need to remember the contents of the conversation. Okay, so basically, here's where we are today. If you have specific, well-defined tasks, yes, generally you can meet or beat what people can do. And by people, I mean experts, right? So all of those medical case studies, it's not, crowdsource the answer and see what happened. No. It's take those people who have been there for 20 years, right? Have a panel of them, right? So you have, a multiple kind of voter agreement, right? And that's what you compare to. So that's what we can do today. And I'm going to talk briefly about 3 things that I've learned about building systems that do that. So one thing, and really if you take only one thing from this whole talk, just remember this. Okay, this is the most important thing to know about NLP. We speak many more languages than we realize. Okay, and what I mean is this. The language I'm using when I'm speaking to you is a different language than I use when I speak to my kids, when I speak to my wife, when I write an email, when I write a text message, and when I write an academic paper. Okay, by different language, I mean that the vocabulary is different, the grammar is different, the meaning is different, right? And the context is different. Okay, and if you think about the way we learn those languages, we actually learn them as separate languages as people. Okay, you join your first job, you understand how they write emails. Oh, you do, right? You had your first, you needed to learn how to do texting at some point and how to do Facebook, right? And if you ever wrote a patent, people walk you through it. Like, here's how we write this, okay? Each one of these. So medical records, if you've seen them, they're great. Everybody loves them. They're just as readable as when they were used to be handwritten. But this is a medical record, okay? So you have all of those sections. 300 milligram oral tablet, 300 milligram, one thing, so a few things to know. So we want to read this. This is what happened to a patient. This is good. Like, this is what doctors would want to read. You want to start extracting, okay, what are the symptoms? What are the vitals? Did we order anything? Like, can we automatically order labs or order prescriptions from the text? That would be nice. Can we understand what happened to the patient? Can we stratify patients by risk? Can we do clinical decision support? All of this starts with reading the text. Things to note. Most of the sentences in English medical records are not valid English sentences, okay, grammatically. Okay, the vocabulary is completely medical. Okay, like, unless you were trained doctor, you will just not be able to read this. Okay, I mean, remember the first one I used to read, the only medical procedure I actually know about is C-sections. Like, we had a couple, right? My wife and I, mostly her. But I remember the first ones I read, I've read one that was about a normal C-section, single birth, and I could not understand that it was a section, right? And I mean, it was really as simple as that. It takes time to do it. What you need is, first of all, just really understand the layout, right? Sometimes you get a scan, you need to understand the layout, you need to understand the sentences, you need to understand where things are at. It's its own thing. Compare it with texting, okay? So texting, yeah, you can look at this example, but it's kind of fairly common example. So let's say I want to read a conversation, okay? Yeah, but this is like, this happens all the time, right? What happens in texting? We do not use complete sentences. We split things between snippets, okay, to say the same things, okay? We do not say who we are speaking to, right? Because it's obvious I'm speaking to you and you're speaking to me, okay? We use profanity, okay? And the thing is, when we use profanity in text, it actually means we are very close with these people, right? This is me talking to whatever, my wife or best friend, right? If I use profanity in a customer service setting, that's really bad, right? That's different. And of course, you have mistakes like, autocomplete and those types of things. So you have inside jokes, you have all of those. You have emojis, which is a language whose entire purpose is sentiment analysis, right? Which you better understand if you want to understand sentiments, because like we just write the sentiment, so you might as well read it. Autocorrect happens, so this is one example. There are other cases. So if you do OCR, right, you have a different kind of errors. Okay, so OCR perfectly reads 15-letter words because it matches them to a dictionary. It makes mistakes on first names or propositions. Okay, if you do speech to text, okay, also there's a specific kind of mistakes that you're going to see, right? You're going to miss really mostly the simple names, okay, mostly things that are not dictionary based. If you read an academic paper, that's its own language. So let's say I want to read papers and I want to understand. Let's say it's medical, so I want to understand, is this a clinical trial? If so, was it a double-blind study? What was the result? What stage is the trial at? Right, those kinds of things, which you should be able to read all of them and do it. And it's doable to build those models. What you need to understand, look, here's how an academic paper looks like. You have the title, which is basically just keyword heavy, right, and a lot of word plays and those kinds of things. You have the abstract. The abstract is the summary. It's a really good summary, right? You use longer sentences, This is the first example you use correct sentences, right? So you use like, well-formed sentences. Don't think they're longer than usual, but usually it's professional written, professionally edited. You need to know that, for example, the first two sections, introduction and related work, are usually not that relevant, right? Because they're not about the work of this paper, right? You really want to read kind of section 3 and 4. And then, further study at the end. That's actually what the article is not about, because this is what other people should do next, right? And then you have the references. But these are domain-specific things you should know. And if you're in healthcare, you get those beautiful things. This is a pathology report. Yes, so a pathology, I mean, it's you might have a tumor, so they take the thing out and they send it to a pathology lab. And they slice it, put it under a microscope, and kind of say, oh, yeah, it seems to be, let's say, it is cancerous. So really, what you care about are things like tumor size, tumor margin, type of the tumor, staging, histology, right? And there are several tens of classic kind of data points that you want to get out of it. Okay, which are here. Obviously, a lot of code, a lot of jargon, handwritten things, right? And what's important, you look at all the previous examples we spoke about. If you have a perfect model for all of them, you're starting from 0 here, right? From an NLP perspective. This is a completely different problem. And if you're in healthcare, obviously, there's email, there's FHIR, there's all these other formats where data comes from. They're more technical. The main thing is each one of them is fundamentally different. What it means, very simply, especially in a pragmatic setting, if you're actually building an application. Okay, the first question you need to ask is really, what language am I solving this for? Okay, and if it's going to take you a few months to build a domain-specific model, it's for one very specific language within a very specific context. And what's going to happen is you will need to tune or train all of these algorithms at every level, right? Because really, the vocabulary is different. Okay, the grammar is completely different. Okay, and definitely if you're doing information extraction, intent classification, entity recognition, those are going to be different. Okay, but the main problem, the first thing you need to realize if you're going to healthcare, which doesn't happen as much if you do retail, if you do social, if you do even cyber. Really, like your tokenizer will fail, your part of speech will fail, your lemmatizer will fail, right? It's not that you need to just do another intent classifier and use off-the-shelf stuff. Okay, so that's the first thing. Any questions so far? Okay, we continue. So because there are many more languages than you think there are, really what you need to do is to train your own models. Okay, and there's a lot of research about kind of say, okay, can we like in 5-10 years not be here? Which is exactly what research should be working on. Today, you need to train your own models. And the first question is, okay, but like really just like, just for my use case, what happens if I just try to do something off the shelf? So here's why you shouldn't, But because we are, in the data space, you shouldn't believe me, and really you should not. Here are kind of the main, the links are here, but you can Google each one of them, it's the first link. Most of the top kind of cloud services and open source libraries have online demos, okay, with a nice UI. So really you have no excuse, it takes you 1 minute. Take an example of documents, you just copy paste it into a browser and you click analyze and you see what you get. Okay, and you will see that you get nothing in the healthcare space. Okay, but like really, like you have no reason to believe me, just do it for your own use case, right? It's a 2-minute thing. Here's one example that we worked on a couple of years ago. These are emergency room triage notes. Okay, so state started last night, after ABD, took Alka-Seltzer, approximately 0.500, no relief, nausea, no vomiting. Okay, this is great. But when I showed it to doctors or friends, they say, yes, like this is good, it's not too long, it has what I need, fine. If you look at all of these sentences, they do not mention the word patient, they do not mention the word name, none of them are valid English sentences. They have their own amazing grammatical structures like, 0.500, 10/10 is a level of pain. You have, plus nausea, which is, great grammar, but like this actually works. And you want to extract really why is the patient here, right? So why do you come to the ER? What hurts? Where does it hurt? When did it start? And you already take something at home so that we don't overdose you, right? Like really simple information extraction question. So this is from a few months ago, from the, I did last in March. From the 6 engines, if you ran them on all of these examples, 2 of them labeled Tylenol as a product. Okay, that was that. That's what we got. Okay, and that's often what you get with off-the-shelf models. Okay, so that's one thing about healthcare. Okay, it's really, it's on completely separate language. Okay, and if you think about it, it makes sense. Okay, like it would take you as much time to understand ER triage notes as it would take you to learn Portuguese at the general speaking level. Okay, like people, they go to school for several years to train for this, right? It's a thing. People do it. It's good. It works. The other thing to consider, NLP models, if you thought that was a problem, even after you train the models, NLP ones generally do not generalize well. Okay, because it's not just that they have their own language, it's that they have jargon. Jargon means that you have internal medicine A on the 6th floor and internal medicine B on the 6th floor, on the 7th floor. Okay, and when you start there on the first day, they tell you, listen, forget everything you learn in med school. This is how we do it here, and this is how we write it here. These are the SB orders. This is how we call them. This is how we document things, and this is how we like doing it. Okay? As a result, if you try to get the machine learning model that you trained on the 6th floor, you get to the 7th floor, you have very interesting results. This is an example from a clinical coding project we did, and basically, this is for outpatient radiology, so we get this one-page radiology report. In this example, we just try to understand what procedure was done. Okay, so was this chest CT with contrast, or without contrast, or X-ray of the pelvis, and there are about 100 cases. Okay, but you think like this is the simplest thing you could ask. What was the procedure? Not even what happened, what are the findings, any of that. And this is an example of a model trained on one customer, used on another, on a different customers. And you can see we had a model, this was typical. We had a model that was 90% precision, almost 90% recall. On one case, that went to around 50% precision, about 10% recall, which is basically garbage, right? So just to understand, right? So 10% recall means that in 9 out of 10 times, the algorithm just returns nothing. Okay, 50% precision means, okay, when it returns something, it's wrong half the time. Okay, so if the product manager is like, just turn it off, it's embarrassing, right? Just,
Just a moment.
Are we okay? Okay. She may have a, it's like, no, we fixed it. While you were speaking, I retrained the new model in the way. But this is also much more common, like in cybersecurity, very often, look, you go from organization to organization, just use the same models, right? Everybody, uses, Facebook, YouTube, and Gmail, and SharePoint, right? And you can do that. In healthcare, really, we see this often within the same building, right? People do not use the same words at all to mean the same thing, okay? So you need to train on your own data, make this assumption. Step 1, the most important step is to label your own data, okay? Which means that you need a clinician within the specialty who understands the job, okay? And the most important thing is to make sure you have consistent labels, okay? And here's another, and this is not for me, this is actually a Yelp review of a restaurant. Okay, if you come for the ambience, you'll be disappointed, but if you come for good and expensive and authentic Mexican food, you're in the right place. So, how many people think this is 5-star? How many people think 4-star? How many people think this is a 3-star review? How many people think this is a 2-star review? And do we have any 1-star reviews here? No, we're good. Okay, so the point is not how many stars it is, but the point is, if we just crowdsource this task to you and says, look, just label this, and then I'm going to train a classifier that looks at text and tells me how many stars it is, okay? The problem is the results are going to be very meaningless, okay? Because we have voter disagreement, we have labeler disagreement. Okay, and what you need to realize is that if you have, for example, 70% labeler agreement, then 70% is theoretical upper limit of accuracy you can reach. Okay? Everything that you do on top, it's by definition, you're overfitting to noise. You're overfitting to random stuff. Okay, this is a big problem when we sell those systems. Right? We do automated clinical coding, and you come and say, we've had this system, it's 99% correct, and okay, we'll have our experts run it. Well, they say it's 55% correct. Right? Because there's no such thing as correctness. There's only agreement. Okay, so that's the main thing you need to be aware of. So, in terms of how much data you need, the main thing is you need data that's representative. So basically decide what you're going to be biased on. Right? Is your model only for older patients, only for younger patients, men, women, different types of cancer, whatever. Make sure data is representative, right? So the priors are correct. And then really make sure that you get consistent labels. That's really where people make the mistake. Okay? one other interesting thing with healthcare is that on the exact same values, different company will have different guidelines. Okay, so for example, if you're looking to get data about cardiology for clinical decision support for cardiologists versus for a pharma company who wants to do real world evidence, okay, like their definition of stages is going to be just different. Okay, because they need it for different things. Okay, so you need to also be specific to use case. Okay, so just to conclude here, one thing we're doing, so the question is what do you reuse, what do you not reuse, right? And we do the Spark NLP project, and we do Spark NLP for healthcare. So you do need to train custom models. You need to level your own data. Okay, when you build a model, you need to do feature engineering, so try different tokenizer, different lemmatizer, different spell checker, different NER model, different embeddings. Okay, and you will need to train your own custom model for a use case. Okay, there are still many things you can reuse. So the actual algorithms, the actual deep learning networks, embeddings, medical terminologies, pre-trained model you can reuse. Okay, so there's definitely a lot of software and data you can reuse. But what you do with them, right, is you don't just call a pre-trained model, use it to train your own. Okay, and that once you do that, yeah, and I think we'll stop at this point. I want to stop at this point for questions. But once you do that, you have your NLP features, right? And then it's the third thing, which is whatever signals you have. So if you extracted entities, you extracted relationships, then you can train them for machine learning model. Okay, so you can come and say, okay, I want to do now patient risk prediction. I want to recommend the next best step for a patient. I want to match patients to clinical trials, right? Then usually you build a classifier on top. Okay, so those are the main things I want to talk about. Are there any questions? Okay, so I'll be around for questions. Thank you very much for listening.